Cool. Um, Today I'm going to send you the recording for the same. Now today we are going to see what is the graphical representation of motion. Now see, in graphical representation, what we have to see is there are two types of graph available. One is distance versus time graph. So we have to represent distance here, and we have to represent time here. And the second is velocity versus time graph. Okay. So the first thing what we are going to see is a distance versus time graph. Okay, let me show you first one. So in a distance versus time graph, let's say this is the situation where we can say this is your motion. Now if you see here, your distance, let's say this is 20 kilometer, let's say. Okay, so let's say you are at 20 kilometer somewhere. Okay, so you are at 20 kilometer. Okay, and what happen is your time is increasing, you are still there. So let's say 1 hour, 2 hour, 3 hour, 4 hour, 5 hour. So what do you think, what kind of graph this should be? If you see here, that it is, as you see here, it is slowly time is increasing, but the distance is not increasing. So what do you think it should be? What kind of graph it turns out to be? Right, what kind of graph it turns out to be? Yes, it is stationary. Yeah, why stationary? Because as you know, the time is increasing but your object is still at the same place. So such graph is called stationary. Okay, so that is what they are trying to teach you here, graphical representation. So first thing, now let's say this is the graph they have given here. Okay, let me show you this one. So here if you see, this is distance and this is time, and if you see the graph goes like this. Now if you see, let's say this is 5 kilometer, this is 10 kilometer, this is 15 kilometer, this is 20 kilometer, right? So if you see, let's say this is 1 hour, this is 2 hour, right? This is 3 hour, this is 4 hour. So if you see here, as it is a straight line starting from a origin, what you can observe here is that the graph is, here the graph is what? Here what happen is the graph is increasing. Okay, if you see, the graph is increasing, right? Increasing in the sense the graph is going up, so the graph is moving. But the important thing is what? It is moving. If you see the difference, every 5 kilometer for 1 hour. So in 1 hour it is increasing by 5 kilometer. In 1 hour it is increasing by 5. Another 1 hour it is increasing by 5 kilometer. So every 1 hour it is increasing by 5 kilometer. What does that signifies? That signifies a uniform motion. Exactly. That signifies a uniform motion. Okay. That signifies uniform motion. Okay. See here, distance versus time graph for an object moving with a uniform speed. Okay. So this is a uniform motion. The first one is a stationary. Okay. Now let's say the next graph you have is like this. Okay, it's like this. So what happen is, here your distance is increasing, but it is not increasing with an equal interval of time. For example, this is 5 kilometer, this is 1 hour. Let's say this is 10 kilometer, this is 2 hour, let's say. But again, if you see, this is 15 kilometer, this is like 3.5 hour. So your distance is increasing. So this is non-uniform motion. What is this? Non-uniform motion. This is the motion what we use to travel every day. So this graph we say is about non-uniform motion. Let me show you here. Okay, so as what I said, this is, now let's say this is one more graph. Here I'm going to show you distance versus time graph, but here if you see, it is going like this. Okay, so the distance is increasing, right? The distance is increasing. If you see, it is increasing, right? The distance is increasing. Okay, it is increasing. Question is, it is increasing, right? So here if you see, this is non-uniform speed, we can also say, or this is non-uniform speed. So we can say this uniform and this is non-uniform. okay, and this is stationary. So based on what kind of graph it is, you have to identify, right? So here this one I can say, right, a non-uniform motion, and the other two which I said is the uniform and a stationary. Uniform and stationary. But let's see the same thing if I want to talk about a velocity versus time graph. Let's say this is your, so what do you think? What kind of graph it is? Just think a little, just think a little. What kind of graph it is? Is it uniform, non-uniform, stationary? What you can think of it? What kind of graph it is? Will it become uniform, non-uniform? Okay. So here if you see this graph, what we are talking here, this graph, what we have talking here is it's not stationary. Yes, I'm sure many must be wondering that, sir, it is stationary. How come it is stationary? It is not stationary. Why? Here this is speed. So let's say you are at 20 kilometer per hour. So let's say 20 kilometer per hour, in 1 hour your speed is still same. Again 20 kilometer per hour, your speed is still same. Again 20 kilometer per hour, your speed is still same. Your speed is not increasing. Your speed is not increasing. Understood what I am saying? The speed is not increasing, right? So it is still the same 20 kilometer per hour. The speed is still same 20 kilometer per hour. Understood what I am saying? The speed is 20 kilometer per hour. Okay. So here this is uniform motion. So one graph may look same in one, but it may be different in other one. So don't get confused between these two. Again I am repeating, don't get confused between these two. Okay. One graph in one, it may look same, in other it might not be different. So don't get confused between these two graphs. So I hope you are understanding what I am trying to tell you. This graph as what I said, they both are not same, they both are different based on how you see it. Okay. So based on how you see, it is different. Clear everyone? So this is uniform, right? So see, I'm going to show you here also. Let me show you this one. See, yeah. So this is distance versus time graph. Here is a velocity versus time graph. Velocity versus time graph is a uniform motion. So sometimes you might get confused between these two graphs. So don't get panicked. Just have a look properly and then try to see. Okay, fine. So we will end it here only. That's it for a day. Tomorrow we'll definitely going to have a live lecture and I'm going to explain you more in detail about it. Thank you.